Welcome, my fellow Sapiens. I'm Umair, and you're watching You, Me, and Everyone Else, where we'll unravel the thread of time to discover how we became the remarkable species we are today. This is essentially the story of you, me, and every sapien you know, the history of us. In the first chapter, we'll see the origins and the evolution of the universe. I'll take you through different eras after the Big Bang. We'll also see how biologists classify things and how species follow an evolutionary path. And we'll end with how Homo sapiens fit in the broader tapestry of life. So let's begin. There are several theories or models that sought to explain the origins of the universe. For example, the flat Earth model, the geocentric model, the galactic centric model, the Big Bang, and the inflationary Big Bang. And they are just a few that explains the universe based on the knowledge and the measurements available at their respective times. While some of these models have been proven incorrect by modern standards, and others were more accurately described as incomplete and have been refined with new data and understanding. For the purpose of this sapien story, we'll go with the theory of the Big Bang. So, approximately 13.8 billion years ago, the universe began with the Big Bang. This colossal explosion marked the birth of space, time, matter, and energy. Initially, the universe was in the state of intense heat and density, also known as the Dark Ages, where no stars or galaxies existed. 380,000 years after the Big Bang, the universe cooled further to about 3000 Kelvin. Electrons combined with protons to form neutral hydrogen atoms. Hydrogen was the first and the most plentiful atom to form, consisting of a single proton and a single electron. And about 75% of the normal matter in the universe today is hydrogen. Helium, the second most plentiful atom, consisting of 2 protons, 2 neutrons, and 2 electrons, making up approximately 24% of the normal matter in the universe. About 13 billion years ago, the first stars ignited, bringing light to the cosmos. This era is called reionization. Around the same time, the earliest galaxies started to form as well, setting the stage for the complex structures we see today. Among these were the earliest quarks and black holes. And as we move forward, around 12 billion years ago, we witnessed the formation of massive stars clusters like Omega Centauri and Galaxies, like our own. The universe transitioned into a matter-dominated era, characterized by the formation of these grand cosmic structures. Then about 5 billion years ago, the universe entered into a phase of accelerated expansion. It was during this time that our solar system and Earth were formed. Roughly 4.5 billion years ago, Earth began to cool, allowing water to exist in liquid form, which paved the way for the emergence of life. Life on Earth began with a single-cell organism around 3.5 billion years ago. Photosynthesis soon started afterwards, introducing oxygen into the atmosphere. This led to a significant increase in the atmospheric oxygen, which is very crucial for the evolution of complex life. Multicellular life appeared approximately 1 billion years ago, followed by the advent of sexual reproduction. The earliest fungi emerged, followed by plants and animals. And this explosion of life about 540 million years ago saw a rapid diversification of life forms. The first mammal were to appear 200 million years ago, and the earliest apes and humans evolved much later, about 6 million years ago. And these developments just highlights how incredibly complex and resilient life is on Earth. About 70,000 years ago, members of the species Homo sapiens, a highly complex organism, began to develop intricate social structures and cultures, a period often referred to as cognitive revolution. The study of these cultures and their development over time is known as history. History's trajectory was significantly influenced by three revolutions. The cognitive revolution about 70,000 years ago, marked by the development of complex language and abstract thinking. The agricultural revolution 12,000 years ago, which saw human transition from nomadic hunter-gatherers to settled agriculture societies. The scientific revolution roughly 500 years ago, which brought a profound transformation in our scientific understanding and methodology, which laid the foundation for modern science and technology. In biology, in biological classification, species are defined as a group of organisms that can interbreed and produce fertile offspring. For instance, horses and donkeys, despite having common ancestor and shared traits, are considered separate species. When they mate, their offspring, mules, are sterile. Hence, they are following a different lineage of evolutionary path. Similarly, lions and tigers, though they are capable of interbreeding to produce ligers or tigons, they are distinct species because these hybrids often have very reduced fertility. Hence, they are on a different path. But in contrast, dogs of vastly different appearances like bulldogs and spaniel, they belong to the same species and they share a genetic pool. Species descending from a common ancestor are grouped under the term genus. For example, the genus Panthera includes lions, tigers, leopards, and jaguars. All cats, from the house cats to the wild cats, they all descend from a common feline ancestor, and then they took their respective evolutionary path. Humans are classified as well. So, for instance, if we go through the categories of human until we come to Homo sapien, we'll see we belong to the domain of Eureka. We belong to the kingdom of animal. Then there is Plantum. Then we go to the class, which is mammals. Then we enter the order, where we are primates. Then we see a superfamily of Hominidae. Hominidea. Then the family of hominids, subfamily of Hominia or Homini, and then we'll see the tribe Hominini, and then genus Homo, species Sapiens. This is how the biologists have ranked the order of the tree. Within this family of great apes, we are grouped into two subfamilies. So hominids and pogonies. Orangutan, for example, belong to the genus Pongo and are known for their distinct red fur and remarkable intelligence. And there are further three species of orangutans. The Hominia subfamily includes gorillas, chimpanzees, baboons, and humans. Gorilla belonging to the genus Gorilla are known for their impressive size and strength. And around 8 to 9 million years ago, the lineage that would eventually lead to humans, Homo sapiens, split from the lineage that would lead to the modern gorillas. And this divergence is part of our larger evolutionary tree. Just to put this into perspective, that would have happened about 320,000 to 450,000 generations ago. From the genus Pan, there are two species, the common chimpanzee, also known as Pan troglodytes, and bonobos. Bonobos are often noted for their more peaceful and social behavior. And about 5.6 million to 7 million years ago, the lineage that would eventually lead to Homo sapiens split from the lineage that would lead to modern chimpanzees, the genus Pan. And this divergence also marked a point at which the evolutionary paths of humans and our closest living relative, chimpanzees, they began to separate. And for you to able to comprehend, that would have been 200,000 to 350,000 generations ago, assuming that every generation lived about 25 years. Humans falling under this subfamily within the genus Homo highlights our close evolutionary relationship with these great apes. This connection highlights our shared ancestry dating back 6 million years ago to a common female ancestor, emphasizing our place in the broader tapestry of life. A hypothetical encounter, if we had a time machine, and if we could travel back 6 million years ago in East Africa, we might see some human-like interactions, from familiar family bonding to social challenges. And these behaviors are similar to that we observed in chimpanzees, baboons, and elephants, which just underscores the ordinary nature. So we concluded all of this, and we have come to the end of the video. Thank you so very much for watching. In the next video, we will meet our brothers and sisters in the form of genus Homo, and we'll take the story from there. If you like the video, please spread the word. If you don't like, leave a comment. Tell me so I can improve, because it's going to be a large, long journey that we'll go through, and I would like to improve. Until then, take care, and remember, we are all made up of stardust. Have a lovely day. Bye-bye. See you in the next video.